Advent of Code 2024, day 23, LAN party. This is OXDF, and I'm doing these a little bit late now. It's actually the 26th as I record this, but I did the 23rd, 24th, and 25th in real time, but I didn't get the chance. I was traveling, didn't have an opportunity to make videos, so I'm going to go back and do that now. Let's take a look. So basically, I'm going to get this long list of connected computers. And a computer is like just these two characters, so like KH, TC, and this top line means that KH is connected to TC. That's a bidirectional connection. And basically, I need to go through and find triplets or like groups of computers, sets of 3 computers where they are all connected to each other. So in this case, like AQ is connected to CG and YN. So if we do AQ, let's see, it's connected to CG. Oh, wait, hold on. There we go. AQ is connected to YN, AQ is connected to CG, and CG, hopefully somewhere here, is connected to YN. Yep, right here on this line. So we just need to find triplets of computers that are all connected to each other. Like I said, I've already solved this, so we have an answer here, but let's go ahead and check it out. I will grab, I'm going to run this one fresh, so we're just going to create a new folder and go with it. Do my gen day script for day 23 here. It creates me a day 23 folder. I can paste the example in here. It gives me my input as well. The example was 32 lines. The real input is much longer, like much, let's see, how far, like over 3,380 lines. And then I've got my stub here. So let's go ahead and get started. The first thing we need to do is think about how we're going to parse the input. If I grab, it's just 2 characters dash 2 characters. So we will say, let's see, what's the best way to do this? We'll say f.read lines like this, and then we're going to do L for L in. So that didn't change anything, but now we can say L dot strip, because we want to remove the trailing white space, dot split on the dash, and that will give me, we'll call this pairs. So this will give me a list of lists where each list has 2 nodes in it. Now, let's see, what are we going to do? We've got that read in. Let's go ahead and create a mapping of connections. So we'll say cons equals, and I'm going to use a default dict here. So we'll say from collections import default dict. And so we can say cons is default dict of set. So cons is a dictionary. If I try to access a key that doesn't exist yet, it's just going to have an empty set there. So now I can say for A comma B in pairs, cons sub A dot add B cons sub B dot add A, and I will now have cons. If I cons of any for any node will tell me all the nodes it's connected to. So now I can just say triples equals set for con in cons. So for each connection, we're going to say for neighbor in cons of con. So we're going to say for each key in cons, we're going to get the list of neighbors, which will be this right here, and then we'll go for each neighbor it has. We're going to say we're going to need to loop again. So now we'll say for next neighbor, I'm going to say like nn in cons of neighbor. Oops. And then we can say if con in cons of nn. Triples dot add. And then so let's talk through what we're doing here. So for each connection, we're going to go through and get its neighbors. And for each of its neighbors, we're going to get their neighbors. And if their neighbors are in the original one, then we know all of them are connected to each other. And so then we can add, and what do we want to add here? Let's see. We want to add con neighbor, NEIGH neighbor, nearest neighbor. And what do I need to actually return here is just a count. Oh, but I need to know. Okay, so we need to, so we can't add a list. Is a list going to work? Let's try this. Python day 23 example.txt. Unhashable type list. So I can't add a list to a set. So instead, I'm going to add a tuple here. And now order, because order matters, I want to make sure I don't repeat. So I'm going to say sorted like that. And so now there'll be these three things we sorted alphabetically. So if I do try to add it again, it won't repeat. And now, let's say part 1 equals len triples. And if I do this on example, 12. Now 12 is the number of triplets, but I only want to count the triplets that have something that starts with T. And so let's see, I'm going to say, let's come here. We'll say T for T in triples. If any, and then we're going to say X dot, so I'm going to say X for X in T. And what I really want is X dot starts with the digit T. So for every T in triples, I'm going to just have itself if, and then I loop over all the things in triples if any of them start with T. And so by that, I think I should get, I think it's 7. Let's see. 7 sets. Okay, so now we can do this on input.text and we get 1323, which is the answer here. All right, so in part 2, we're no longer interested in trying to find triples or triplets. Now we're going to try to find the largest set of computers that are all connected to each other. So, and then in this example, like all of these computers were connected to each other, giving us co-data, and we need to generate that from there. So, we're going to do roughly the same thing. We are going to have, we're going to need a function. We're going to have to use a recursive function to dive into this. So we'll say def build set con, which is a string, and we'll take a group, which is a set of strings like that, and we're going to return none. And the thing, I remember this took me a while to figure out in real time, but the thing we're going to do here is we're actually going to define passwords, because we're joining all these together to form a password, which is going to be a comma separated list. So we're going to say password equals set, and we're going to record all the passwords. And the thing that took me a while to figure out is we're going to have this, I spent a long time with the recursive function trying to figure out what to pass back and what to pass up. And instead, if I just set things, if I just update things in this set right here, or within passwords globally, it worked out much nicer. So now we can say password equals comma dot join. So at the very beginning, the base case is going to be sorted group. So that group gets added to the password list because we're not going to call this unless we have a valid group. If password in passwords, so if we've already added this, we're done. We just stop because we've already been here before. We don't need to do it again. It's like a scene in a breadth first search. Otherwise, we're going to say passwords dot add password. Now we've added the current group into the passwords. Now what else into the larger set. So now I can say for neighbor in cons con. So for every neighbor in this thing, if neighbor in group. So if the neighbor's already in the group, we're just going to continue. And then we say if any neighbor, so if any of the neighbors is not in, let's see, what am I trying to do? I'm going to loop over all of the nodes in the group, and I'm going to see if the neighbor is connected to all of them. And so what we want to do is say neighbor not in con of node for node in group. So we're going to loop over all those, and then we want to say if any. Okay, so if any of these things, if any of the neighbor, if the neighbor is not in the connections for any of the node in the current group, we go over all the nodes in the group. If the neighbor is not in any of those, then we're just going to continue. We're done. We don't continue. Otherwise, now we've checked a neighbor that's not currently in the group, but everything in it is connected to it. So we're going to do a build set on neighbor as the connection, and we're going to need a new set. We can say group, which expands out the group, and neighbor like that. So we've just basically created a new set with all the things that were in the group before. The splat operator effectively takes that and blows it out into its individual components. So all of them comma separated, and then neighbor, and now we have a set, and we're going to pass it through. That is basically what we need to do. So now we can say, we'll say for con in cons. So we do have to start with every con. So we can say build set of con. And that'll give us sort of a starting point where we just run through. And now we can say max passwords key equals len. So that'll say for everything that's in passwords, apply the length function, take the biggest one, and that is our part 2 response. And we might be done here. That's clearly wrong. We want to do that. And let's see what we get. We get the code kata, which is what we what we got there. And you can see down here. And if we do it with our input, it runs. It does run for a second. I should have timed it. But we get the ER, FH, FIIR, ER, FH, which ends up being my answer. So I thought this was a neat problem. Again, the thing that really broke it open for me here was the idea of adding these passwords to a set outside the function so that I didn't have to try to trace passing these things back and forth and tracking all the different groups and how to join them. I don't think it'd be too hard, but I just kept making mistakes and making just little errors. And I don't think this is something you want to necessarily do in production code, but it worked really nicely for this challenge. So thanks for hanging out with me today. And I will hopefully finish up 24 and 25 very soon. I'll talk to you then. Bye.